Hello and welcome to my talk, CI/CD that spans the seven Cs. That's a mouthful. This is track number one on IoT Day, so hopefully I don't let you guys down. So some background before we get started. My name is Brian Foody. I'm lead developer on the MarineLink Smart product at Oscillator, which I'll be talking through today. I'm an Irish man living in Perth, Western Australia, enjoying the sunshine. Had a nice sea swim this morning. I've been building tech products for 10 years. My focus is very much on event sourcing, BDD, cloud native, and user experience right now. I'm a lot more product focused. I like to leave the low level tech to people like AWS as much as I can. My pastime, sea swimming, which I mentioned, and trying to grow my own veggies, which is going pretty well right now. So touch wood, it continues. About Oscillator, where I work, Oscillator Global shipbuilder for the commercial and defense markets, where they design, construct, and support revolutionary vessels. So you can see some of the vessels there. The most recent I was on a sea trial was the Fred Olsen Express, which is a 118 meter catamaran that can move at 37 knots. So it's quite the experience being out on the ocean with them. I really enjoyed my day out. So if you ever get the chance to be on an Oscillator vessel, I highly recommend it. They are revolutionary vessels. Oscillator have operations in Australia, Vietnam, Philippines, and the US. So Oscillator is also expanding more into the technology space. So I want to go beyond the ship delivery with our customers and go on a journey with them into their operations to help improve their operations as much as we can. So there's two core products that we're developing. One is the MarineLink Prime, which is a monitoring control interface with a 3D interface, which is new to the industry. And then there's the MarineLink Smart product, which I lead the development on. Your crew teamed with artificial intelligence. So let's see a bit about that product. MarineLink Smart is an onboard advisory system using IoT and state-of-the-art artificial intelligence algorithms. So it continuously monitors and analyzes vessel data, and that data is then synced to shore for model training. Ashkan and Assad, our data scientists, take that, train the models, do some really smart stuff with it. We take the model then and do the less smart stuff, and we take it back to the ship, and we run that on the ship at the edge, and we serve that up to the customers. So we use the real-time data to feed into that model to provide the optimum settings to our customers to ensure that the ship operates in the best way it can. You can see some of the advice that we recommend here, which runs on board a tablet. It is an advisory system, so it doesn't update the system automatically. The crew look at the advice and then implement it. So about the team, there's 7 of us in total, spanning tech to data science to hardware, electronics, design. A small multidisciplinary team, the kind of team I like to work in, where you get to work on a lot of different problems each day, and it's very exciting. So about the MarineLink Smart product, a bit more about it. So between September 2019 and February 2020, the initial prototype of it was run on Bocania Express, a Fred Olsen vessel, which runs in the Canaries. So over the course of 15 individual journeys that happened over that time period, when the crew followed the advice from the advisory algorithms, they saved a total of 4.5% of fuel on each journey compared to when they didn't follow the advice. So you can imagine a 118 meter catamaran running at over 30 knots, 4.5% of fuel savings adds up to a lot to the bottom line of the customers, but it's also a lot of savings for the environment as well and fuel consumed. And the other thing that it's quite apparent is basically the intelligence in these algorithms. To save 4.5% on journeys where crew that know this route intimately and run it up to 10 times a day during peak season, for the machine learning algorithms to be able to save 4.5% on that is a key indicator of how good these models are. So I joined the team with the task of scaling this up from the 1 ship it was on to initially 10 ships and then 100 ships. So I thought I was going to come in and just press the scale button. As we all know, there's one of them with technology. It's easy, but it didn't turn out to be the case, as I've always found with technology. So as we scaled, some problems became amplified. So there's me with the wooden wings. That was very much me for the past few months scaling this up. Our original deployment had contained lots of manual undocumented changes. So as is the case when you're doing research, the initial product had been sort of built in an organic way. So we'd made changes, but they weren't made in a repeatable way. So when we went to take this product and scale it up to 10 ships, there was a lot of manual steps that had been missed along the way. So we deploy it to a vessel, we'd find a problem as it went, and we had to keep updating the ship, and the defect rate was quite high. And as we went along, it also became quite hard to manage and update the application. So it was evident that it was not easily repeatable and it was not easily scalable to add more updates to these ships. So why was that? Let's take a look first at why that was before we look at how we changed that. So Hostel used Apache NiFi originally for the proof of concept. So Apache NiFi is a really good tech product. It's sort of like a Swiss Army knife for IoT. So you can collect data with it. You can attach that data to different process groups where you can do data transformation. There's lots of custom processors that allow you to do business logic. And it has a site to shore sync where it'll allow data to be backed up until there's a connection, and it will sync it to a shore instance, which is running on an EC2 instance. So one of the problems with this, there's a few problems with it, but the main one was, updates couldn't be deployed programmatically, I should say. So you had to update each ship. Each ship had its own Apache NiFi instance. To update those ships, you had to go onto them, right-click on the user interface, and click Update Process Group, which you can imagine as you scale up, that becomes harder and harder to do. You also need a connection to do it, so you need to know where each ship is in the ocean, time your update, make sure it happens within that time, execute your test to make sure it didn't break anything, and then over time it becomes quite hard to manage all of that. You have a checklist of each ship that you're updating. The system is programmed through the UI, meaning little test coverage. I don't know how many of you have used NiFi. It's actually quite quirky and you can get into it, but you can also get yourself into a lot of trouble because it's so easy to drag these boxes around. You can change things without really understanding what you're doing or what you might be breaking downstream. And there's no test coverage to catch that. So you can go in and make changes, but you might break something without really realizing it until the customer finds that issue. So that low test coverage was really a hurdle for us. It's not designed to horizontally scale, so Apache NiFi is not a cloud native product. So things that you take for granted in cloud native, like something like Kinesis, horizontally scaling, with Apache NiFi, that's extremely complex. We really struggled to scale it up to run in cluster mode, and really we realized it was so much complexity and management for something that comes natively in the cloud and which we were adopting very little of. So while this MarineLink Smart product was technically in the cloud, it wasn't really making the most of all the cloud native technologies that were ready to be adopted. So in summing up, NiFi had become a bottleneck. It was very developer unfriendly. It was good for hobby projects, good for one-off use case I could see perhaps, good for research phase and proof of concept, but in scaling up a commercial product, it had run its course for us. It was not going to work. At 100 ships, it would be a whole team managing just the operations of it. So back to the mayoral board for us. How are we going to scale this project up to 100 ships? So we touched base with Mechanical Rock here in Perth, who are a cloud native practice. And after our meetings with them, we came back and we focused really on the 4 key metrics from the state of DevOps. So the researchers there determined only 4 key metrics differentiate between low, medium, and high performers. So the chasm between low performers and high performers is vast. Until I seen the numbers, I didn't quite believe it. So 208 times more frequently high performers deploy to production, and 106 times faster lead time to get them out there. So these were 4 key metrics that we wanted to follow to guide our scaling of our product. Simple yet powerful tool to help us focus on measuring and improving what matters, which is getting product in front of customers. So the first of those metrics is deployment frequency, the number of times you're going to deploy per day. Per day was not a concept we understood at that time with this product. So if deployments are not automated, you won't deploy often. It's quite paradoxical for some people. You think the more you deploy, the more your defect rate and the more issues you're going to have, but it's actually the opposite. The more you deploy, the less issues you're going to have. So for us, the manual nature of NiFi deployments to a global fleet moving in and out of connection led to reduced deployments. It really was quite painful to get a deployment out there. You had to, like I said, catalog each ship, go in, manually update them, make sure you didn't break something. So that meant we were deploying about once a week when we wanted to be deploying intraday. So the lead time for changes is another metric, the time for work to be implemented, tested, and delivered. You can tell once the manual testing is introduced there that this lead time for changes is going to be pretty vast. So I guess the best in the industry can get code in production within half an hour. When you're manually testing, that's pretty impossible. So the manual testing required to gain confidence made it impossible to get code to production within a day. It was really a couple of days, to be honest. So we needed to reduce our lead time. Then the change failure rate. So of those changes you're getting to production, how many of them are raised defects? So obviously for us, if we're deploying only once a week, it's a bigger payload. And probably every second week we were finding we were getting some sort of defect with it. So close to a 50% failure rate. And when we actually went to document the test, we could see why that was. There's so many scenarios to run through, and manual testing, it was very hard to run through all of these every time when you made a change. So getting the automated tests in place was key for us to make sure that we were automating all of that. Next key metric, time to restore. So if you do raise a defect, how quick can you fix it? So you want to keep that momentum of delivery going. If you break something, you don't want to be off the rails for long. So due to the lack of observability and logic within NiFi, discoverability was a huge problem. So even knowing there was an issue was a problem, first of all. And then the manual nature of the deployments meant undoing changes was equally as difficult. We basically had to repeat that manual process to roll back or forward fix. Forward fix was hard because you had to do manual testing. So you can see it sort of starts to grind to a halt as you get more issues. So rethinking our approach, thinking about those key metrics and how we could improve them, we came up with 4 sort of key strategies that we were going to adopt to help improve those metrics for us. Number 1, deploy from source control. No more right-clicking on a user interface, upgrading. To increase our deployment frequency and lead time for changes, we knew we had to have the stack deploy from source control. So we needed our code pipelines in place, needed to be check into source control, and the system took care of the rest. This was really the key ingredient number 1 we wanted to get in place. Number 2, automated testing, which we've touched on. So if you want to have the confidence to deploy daily to a ship of fleets and provide advice to them, you really need to be tight on your testing. So we wanted our test coverage to be as close to 100% so that we felt that confidence come back to the team in deploying to production daily. And now we have that pipeline in place, churning through a growing number of tests, which gives us confidence in the platform. So you can see in under 3 seconds, we've executed all those tests that would have taken a few hours to execute before. And then BDD, which is something that we were very keen on putting in place. So there's no point putting all these technical tools in place to update your product if the business don't trust you to do that. And really for us, we wanted to start communicating more with the business. Issues were happening and we weren't communicating properly with them. So we knew we needed to go on a journey with the business to get these metrics improved. So Max, our product owner, was very open-minded. He came along to a workshop with Mechanical Rock where we did a BDD workshop and training around this. We came back the next day and we actually got to the bottom of the main problem that had been annoying us for a long time. We example mapped it, put our acceptance tests in place, and got to the bottom of it and solved it moving forward in an automated manner. So BDD gave us that framework for communication and shared understanding between the business and the development team. So I had actually been using BDD more as a testing framework. The workshop really exposed to me and working at Oscillator that it's about communication and shared understanding more than any testing that you're doing. And then the next one was more the classic case of monolith, microservice, event-driven. But really NiFi was this huge monolith, which meant that it was hard to update and not break something. There was these huge bundles going out to production. If we wanted to deploy more frequently, we needed to carve that up and just update each component in isolation. So to reduce the payload of each deployment, we needed to decouple the NiFi components. But in tandem, one of the benefits of this is that it would give us a stream of events that we could observe to detect any anomalies. So we went back to the drawing board, did our event storming session, put all the events up, broke it up, got our processes in place, and then created our event-driven architecture from all of this. And now we have a clear understanding of the application and visibility in a Miro board for any changes going forward and how they'd impact the system. So what does version 2.0 look like? I'm sure you're all on the edge of your seats, so let's have a look. So it is no surprises here if you know me. It's a completely cloud-native stack. So we have Greengrass. We're adopting Greengrass in place of NiFi at the edge. So Greengrass, I like to think of it as an arm that reaches out from the cloud, and it has our application in its hand. And from there, all the logs from that, all the data is fed back into the cloud, where we have Kinesis ingesting data, which then spools it out to S3. We had a spike with TimeStream, but it wasn't quite there for us, so most likely it's spooling to Timescale DB. And then we have the events coming through to AWS IoT and an EventBridge to really unlock the business. So some of the benefits from this architecture. Number 1, thankfully, updates can be rolled out over the air, so we no longer need to manually execute these updates. We can tell Greengrass to update the application when we want programmatically, and it will do it for us across the fleet, which is really powerful for us. That checks number 1 for us, deploy from source control. Then we have simple node apps written in TypeScript. So instead of user interface logic embedded deep within process groups in NiFi, really it's just simple node apps written in TypeScript. Really, it lends itself to TDD within our BDD framework. So we go from 0 to 100% test coverage and a much deeper understanding of our application. Alongside this, we have unlimited scaling of ingest through Kinesis. We're never going to overload Kinesis as we scale up. I don't think there's enough ships in the ocean to do that. But more importantly, I think, is that it's very easy to add parallel consumers without affecting the main data pipeline. If we want to attach to this rich stream of data, Before there was a fear around NiFi because it was running as a single bottleneck that we would break it. So now that fear is gone and we know we can harness this data and do what we want with it, which is ultimately what you want from IoT. I think that I'm very excited about. When issues did happen, it was very hard to understand how the system had got into that state. So Max would ask me, how did this happen? And I'd really have to struggle to try and recapture all the events that led up to that because they were embedded within NiFi tangle of process groups. Now events are a first-class citizen which go through a central log, meaning all logic that triggered a device is captured as a replayable stream. So anytime our customers ask us, hey, why did you trigger this advice? It didn't seem quite right. We can capture all the events that led up to that. All the inputs and outputs are captured as events and all the data surrounding it. We can replay that, look to see if there was an issue or if it was just something to do with the environment at the time, feed that back to the customer. And if in that case we were wrong, we can improve our process so that it doesn't happen again. And we have inherently our tests that come from the events that were created. So with this rich stream of events, we also stream it back to the business. So these events that are happening across the fleet, across the world, before were quite isolated within this NiFi framework. Now we're feeding those events into EventBridge, and the whole business can attach to these events and do their own workflows in real time. So they can drive real-time decision making across the business. If a fleet manager asks us to be alerted when a ship is running a few minutes late, new workflow put in place. It doesn't have to affect the work that happens for us in the core business and collecting the data. So I guess with that framework in place, we ultimately became the first consumers of this framework. We have a parallel consumers of the data. We have the data coming in from the edge. We have a programmatic way to update it. So now what can we do with that to really improve our processes and really start to harness this data? So number one, we have contextual awareness of ship locations. Every time a ship docks after a journey, we send a ship alongside event into EventBridge. This updates a database so we know where every ship is at that point in time. So the great thing here is that the developer can focus on the product. They no longer need to worry about where each ship is in the ocean. We can focus on writing our tests within our BDD workflow. We can commit our code. It goes through the PR process. And once it's merged, it generates a code commit event in EventBridge. This triggers our step functions workflow. So we use a lot of AWS developer tools now to build it. We have some shared packages. We have some Docker containers. That is orchestrated through a step functions workflow. And when it's successful, it creates a release event to say, hey, there's a new application to release. Please release it. And listening to this then is another step functions workflow, which basically just paralyzes for every ship in the fleet to go and update it. So it will take, for every ship, check, is the ship alongside? Can I update it? So this is basically what the step functions workflow looks like for each ship. Where is each ship? Can I update it? So in this case, imagine we had 5 ships. We can see that 2 are pending arrival. So we're not going to update that ship while live advice is going on a live journey. We're going to wait for them to reach the shore. There's 2 ships that we can update straight away. So we roll out the application to them and end the workflow, send an event back. And then there's one, you can see we can add more logic to the workflow. We can enrich that with journey advice, so we know the timetable for the customer, and we can say, oh, this journey is leaving in a couple of minutes. Better not to update it just yet. Let's wait. And then the next time it comes back alongside, we'll update it the next time. So really exciting stuff, really taking away the minutiae daily updates and letting us focus on making changes. So in conclusion about IoT, I think when I joined Oscillator, I was new to IoT, and it's such a broad, expansive space. It's so nebulous. There's so many technologies. But I think once you ultimately focus back on what IoT is about, which is enriching your organization with data and events from the edge, that can really drive your development. So really you want to feed, I guess, success will be defined by how easily your employees can harness the data. It won't be defined by how cool your tech stack is. It'll be how many people in your organization are using this data and doing things with it. So you can see there we have an easy TypeScript library where you can attach to any event from it and create your own workflow. If you want to do something when a journey is created, create a new function, deploy a Lambda, attach it to EventBridge, away you go. So feeding events into EventBridge creates that real self-service platform for your company and really feeds innovation. So you can get that flywheel going of innovation. And without us being a gatekeeper to the data, by putting that into EventBridge, the organization can flourish and innovate with that. So what's next up for us? Now we have our pipeline in place. It's ultimately about improving the product. So before we were giving a single RPM advice for journeys, now we're going to move towards giving dynamic advice throughout the trip. So really there's a cost function running continuously. We want the customer to arrive on time, and throughout the journey that cost function is continuously running, trying to minimize the amount of fuel that the customer is going to use, so that they get there with the minimum amount of fuel used. If the weather changes throughout the trip or other conditions change, we'll update the advice throughout the journey, let the customer know that they can slow down a bit and they'll still get there on time while reducing their fuel consumption. So really exciting times ahead. Thank you very much for listening to me today. I hope you made it to the end, and I hope I can answer your questions here afterwards. Thank you kindly. Cheers. See ya.